So today we're going to get into lesson 4.6, which is over arithmetic sequences. This is actually a very, very easy section, but it does need to be covered because it pops up quite a bit on the state test. So arithmetic sequences is definitely the beginning of this slide or this presentation that we're going to go through is very simple. You might have some different bigger words like obviously arithmetic sequences you probably haven't heard of, but don't let the words confuse you. The actual math of it is not too difficult. So first we need to know what the definition of arithmetic sequence is. It's an ordered list of numbers in which the difference between each pair of consecutive terms or numbers in the list is the same. That sounds like a lot, but it's basically what we've discussed before. It's talking about having that constant pattern. So it's saying you have the same difference between each pair of consecutive terms. So numbers that are in a row, they're going up or down by the same amount each time. So that becomes an arithmetic sequence. So this says a sequence is an ordered list of numbers. So this is kind of just touching on what we just said. Each number in the sequence is called a term. Each term, A subscript N, AN, so that, make sure you know that symbol because you'll use it or see it often, has a specific position in the sequence. So, like 5, here's a sequence, 5, 10, 15, 20, 25, so on. This 5 is in your first position. So the 15 is in your third position. And if you keep going, all the numbers after that, AN is in the nth position. Okay, so that's just something you need to know. But basically that's just saying that could be any position. They could say 50th position, that would be A subscript 50. So that's something you'll be able to see or something that'll pop up later on. Arithmetic sequence. Again, this is more just touching on what we've talked about. The difference between each pair of consecutive terms is the same. This difference is called the common difference. So, whatever that common difference is, or whatever that difference, whether it's increasing, decreasing, whatever, is called the common difference. Each term is found by adding the common difference to the previous term. So, looking at this example again, 5, 10, 15, 20, your common difference is plus 5, because that's what they're doing each time. 5 to 10, you added 5. 10 to 15, you added 5. 15 to 20, you added 5. So all of these, 5, 10, 15, 20, are your terms. They're called terms of an arithmetic sequence. This is your common difference, adding 5 each time. Okay, so that's more of just the vocab and understanding all of that. Actually, picking out the terms is pretty simple. So it says write the next 3 terms in the sequence. You have negative 7, negative 14, negative 21, negative 28. So it doesn't take a lot to realize what the pattern is here. Every time you are subtracting 7. So from negative 7 to negative 14, you subtracted 7. From negative 14 to negative 21, subtract 7. Negative 21, negative 28, you are subtracting 7. So that means your common difference is negative 7. Your common difference in this arithmetic sequence is negative 7. So if they want us to find the next 3 terms, my next term, if I do negative 28 minus 7, that's negative 35. And then just keep going. Negative 35 minus 7 is negative 42. And negative 42 minus 7 is negative 49. So there would be your answer, negative 35, negative 42, and negative 49. You're just following that same pattern each time. And in this case, it was subtracting 7 each time. That was my common difference. So I want you to try this on your own. Pause the video. Try this. Once you start it back up, you'll see that your common difference from 0.2 to 0.6, you added 0.4. From 0.6 to 1, you added 0.4 again, and so on. So That means your common difference here is adding or positive 0.4. So then I just continue that pattern to get my next 3. 1.4 plus 0.4 is 1.8. 1.8 plus 0.4 is 2.2. 2.2 plus 0.4 is 2.6. So there are your next three terms in this arithmetic sequence: 1.8, 2.2, and 2.6. So just identifying that common difference is all you need to do to be able to just get the next three in that sequence. They also might ask you to graph arithmetic sequences, which isn't too bad compared to what we've done before. But pay attention to what they want here. It says to graph a sequence, let a term's position number n. Position number means what term it is in the sequence. So there's a first term, second term, third term. Be the x value. So whatever that term is your x value in that ordered pair. The term itself, a to the n, or an, is the corresponding y value. So this is how you plot these ordered pairs. N, comma, an. So what that means is the position is your x, the actual term itself is your y. So this will make more sense if once we look at an example. So it says graph the arithmetic sequence 4, 8, 12, 16. So basically, these are your y values, because these are the actual terms themselves. The x value, remember, is your position. So this 4 is in the first position. That's my first term. This 8 is my second term. 12 is my third term. 16 is my fourth term. So that means my ordered pairs are as you can see, 1, 4, 2, 8, 3, 12, 4, 16. So those are the ordered pairs you are going to plot when you graph this. So all you're using is the terms themselves are your y, the position they are in, first term, second term, third, fourth, those are your x. So that's how you come up with your ordered pairs. So I'm going to make a graph real quick. Okay, so then I'm just plotting these. Remember, x goes first, so I go over to 1, up to 4, there's a point. Over to 2, up to 8, there's another point. Over to 3, up to 12, that's another point, and 4, 16 is your last point. So, when you graph this, you should notice something. With arithmetic sequences, when graphed, they're always in a straight line. They will always fall in a straight line if graphed correctly. So, this one will have a graph looking like something like that. And again, my graph isn't perfect, but you get the idea. Anytime you graph arithmetic sequences, you will have it fall in a straight line. So if it's not a straight line, if it's curved or it's scattered all over the place, that means you do not have an arithmetic sequence. So that is what it would look like if you were to graph these arithmetic sequences. All right, so now let's get into the actual equation of an arithmetic sequence. Because this is what's going to be used the most and what will be the most helpful in doing problems, because sometimes they might just ask you, they might give you a sequence, but instead of saying find the next 3 terms, they might say find the 100th term. And obviously you don't want to list out all the way to that. So there's actually an equation that can help you plug things in to get that. It says let an be the nth term of an arithmetic sequence with the first term a1 and the common difference d. So whatever your first term is, that's what A1 stands for. It's your first term. That's where you plug your first term in. The common difference is D. So whatever that common difference is, which we've discussed how to find that, that's what you plug in for D. The nth term is given by this equation. Okay, and I'll show you how we break that down. But that is what we're going to use to find this nth term, whatever that nth term might be. So let's look at this example real quick. Give me 1 second. Okay, so it says write an equation for the nth term of the arithmetic sequence 14, 11, 8, 5, ... then find the A50. So there's two things we have to do. First thing, we need to write the equation. So from that last slide, you'll remember we have the equation for an arithmetic sequence is AN equals A1 plus parenthesis N minus 1, and then outside the parenthesis is D. So, two things we're going to plug into this equation. One is our A1, whatever our first term is. Our first term in this arithmetic sequence is 14. So, I'm going to bring down A to the N equals, in place of A1, I'm going to put 14 plus N minus 1, and then D, that stands for my common difference. If I look, we got to think, what is my common difference? 14, 11, 8, 5. Every time you are subtracting 3. So, that means your common difference is negative 3. So, in place of D, we're going to put negative 3. So, to get the equation, we just have to simplify this sum. So to simplify this, first of all, and this might look a little weird because you're not used to it like this, but you can actually distribute this negative 3 to each term on the inside here. I know you're used to it being on the front, and then you distribute this way, but if those two are multiplying, you can still distribute that the other way as well. So I'm going to bring down my 14. Negative 3 times n is negative 3n. And then negative 3 times negative 1 is positive 3 or plus 3. Lastly, I'm going to combine my like terms. Negative 3n, there's no other n's, so it can't combine with anything, so I'm just going to bring it down. But 14, positive 14 and positive 3, they can combine to be positive 17. So, for the first part, it says write an equation for the nth term of the arithmetic sequence. There's your equation. A to the n equals negative 3n plus 17. So, they want us to find A50. So, A to the n becomes A to the 50. So basically, we're finding what that 50th term would be in this problem. So, what I'm going to do is I'm going to plug in 50 n for n, and that's how we're going to find this. So, negative 3, in place of n, we put 50 plus 17. And then you're just working out the math. A to the 50 equals negative 3 times 50 is negative 150 plus 17. And then finally I simplify that. Negative 150 plus 17 is negative 133. So basically what that's saying is, if you were to continue this pattern, subtracting 3 every single time, when you get to that 50th term, it will be negative 133. Like I said, there's test questions just like that, where it might ask the 70th term, 80th term. You don't want to have to take 20 minutes to list all those out. You just use this equation, plug in your A1 and your D, and then once you simplify that, you can plug in your N, which whatever term that is, and that's how you get your 50th term. So, let's look at another one that you can try on your own. One second for it to load. Alright, so this says write an equation for the nth term of the arithmetic sequence, then find A25. So they want us to find the 25th term now. So, there's your sequence. And again, you're going to use this equation, a to the n equals a1 plus n minus 1 times d, to find your 25th term. So, a to the n equals, I plug in my a1, which my first term is 4 plus n minus 1, and then my common difference, which obviously you can see they're just adding 1 each time, so your common difference would be positive 1. Then we simplify this, a to the n equals 4, 1 times n is n, 1 times negative 1 is negative 1, so it'd be plus n minus 1, combine 4 and negative 1, you come up with the equation n plus 3. So this is actually a pretty simple one compared to the last one, but that is your equation. So then, to find A25, we just take 25 and plug it in for n. So it would be A25 equals 25 plus 3. Simplify that, A25 equals 28. So there's your answer. That would be your 25th term. 28 would be your 25th term. So like I said, this section is not too difficult. It's over arithmetic sequences. You're just trying to find that common pattern, that common difference, and then the main thing I want you to make sure you can do is this at the end. Obviously you can see the sequences, that type of stuff, but I want you to be able to, and you can graph them, I want you to be able to use this and plug in whatever term they want you to find, because that's the main thing that you will be asked to do, and that's the overall idea of this section. Okay? So make sure you can do that. I think you'll be okay with this section. Thanks.